Let me take off the xenon here. So this is a particle squared. Zoom in a little bit if I can. It's got two different sensors on board, and then it also has the external sensor down below, and I'll show you in a second. But it's made to work with any type of feather compatible board. So that includes the new mesh boards from Particle. So this guy is a Particle Xenon. And you can also use it with a board like this ESP32 breakout board. I think this one's called the Huzzah from Adafruit. Just a couple examples of what you could use it with. Anything that can connect to the internet is ideal. You can also use it with anything that's LTE powered. So I have a boron over here that I can easily plug into it and start running. So it's got two sets of headers. It's meant for, you can directly plug it in kind of standalone, like this. You can also, instead of these headers, you can always put the kind of traditional ones on there. You can put male headers on the outsides if you want to actually connect it to other things. On board, there's also a connector that goes to the particle sensor right here. There's also some power circuitry on here. So what that means is that you can use this sensor when this board is either connected to battery or USB or both. So it'll automatically switch between the two to make sure that this sensor gets the right voltage. This sensor requires 5 volts. So this board makes sure that you get that 5 volts so it can work. Going into the other sensors here, I think get a little bit closer. So this guy is the CCS811. This is the Ams Chip. You use it for TVOC and CO2. Total organic volatile compounds. They can be found in the air naturally, but they can also be found from things that are off-gassing in your home, chemicals, just name a thing, and it'll be emitting VOCs. CO2. CO2 is what we exhale. So the more CO2 in the room, the less oxygen is in the room. So, and I believe that the CO2 is also correlating with the VOCs as well. What I've seen in my testing is that the VOCs, for the most part, will correlate with the CO2. Different values, but they do. The sensor right next to it, this guy is the is an SI7, was it 27? SI7021. So it is a combination humidity and temperature sensor. This particular one, if you look carefully, it has a cover on it. So this cover comes with it from the factory. It'll protect the sensor from dust and other things that could potentially get in there. It still works just as well with it. So I generally, the boards that I've built here all have that option. Obviously, you can see the board design. The way it was intended is this: you can put the TVOX, the particle sensor here, plug it in. The air flows from here out that fan, and then across these sensors. So if you had it in an enclosure or something, you have a nice airflow across these sensors and then out the exhaust port or whatever. That way you have a nice constant airflow or fresh airflow whenever this is turned on. In the code, if you guys check out the code, I'll have a link to that in the description down below. But the code will actually only run this for about a couple seconds just to get a new reading and then shut off. The main reason for that is that every time you run this motor, it's about 100 milliamps or so. So if you actually were running if you're running this board, if you're running everything together on a battery, you'd kill that battery pretty fast. Let's see, what else? Nothing on the backside, it's just one side. So, and for anybody who's interested, this does have some version information. So this is the board number, but the last number is the board version. I like to put that stuff in there, and I think I also have a date stamp. Let's see, right along here is the date. So let's see, and then other than that, you got the standoff, so you can place it. These standoffs are the same size as a feather standoff, so if you look at this guy, they're the same exact holes. To put this guy together is literally as simple as that. Previous versions had these crisscrossed, so this is the latest version. They're straight across, so it should look like this. Earlier versions would look like this. So, and then you can plug in your other board on top here. Another thing to note is that the communication between these two guys is through UART. The Xenon boards actually have two hardware UART interfaces. The argon and the boron only have one. So remember that if you are using the setup with an argon or a boron, it only really matters if you're starting to interface or work with other sensors that are also on UART. The Xenon has two because it doesn't have any external radios. So argon uses UART to talk to the ESP32, and then for the boron, it actually uses it to talk to the U-Blox LTE modem or the 2G, 3G modem, depending on which version you have. So I do have some example code under a different branch where I have put a boron on here with this, and it's also sharing with one of the Adafruit GPS modems. So that is I'm going to be talking about that project a little bit later on, so stay tuned to the channel because I'm going to be posting about that very soon. Let's get this up and running and see what type of information we can get off of it. And then it's going to start connecting to the gateway I have here. So this is just a particle boron, which is connected over LTE. I actually put in a different SIM card. It is using a Soracom SIM card. You pretty much can use almost any SIM card with this device as long as the network supports it. So this guy uses Cat M1, which is like the new technology for M2M, machine to machine. As long as the network supports that, you're good. Both AT&T and Verizon does support this type of network, so you shouldn't have any problem in the US. If you're outside the US, I would check into whoever is your main provider, make sure that they do support it. So this guy's it's got a U-Blox module, and it's got a Nordic NRF 52840, which is like kind of their newer series, which supports Open Thread, which is basically what these guys use to talk to each other. So whenever this guy takes a measurement, it will send kind of a low power message over the Open Thread protocol to this guy. Then it'll be forwarded on to the internet. As far as I know, that these guys use kind of a UDP connection to the internet, so it's not as reliable as TCP, but there's a lot less overhead. So they're both connected. This guy is glowing blue, so I'm gonna check the web interface. We'll start with the particle, and then we'll go over to Grafana. So I've opened up the console particle, and this is how everything looks. The most important information usually comes down in the events dialog here. So I've sped up the sensor readings to about every 20 seconds. The default is every 2 minutes. So you can see there's some new data coming in. It has the temperature, humidity, TVOC, CO2, PM 2.5, and PM 10. What I've seen so far in my testing is that these two numbers are pretty much about the same. Honeywell did come out with a new sensor that has a couple of different levels. I think that one might kind of differentiate between the two a little bit more. And then let's see, temperature, this is in degrees C, humidity is kind of a relative percentage. TVOC is in parts per million, and then CO2 is parts per billion. It might be swapped. I don't quite remember. The important part is, I have it sorted out on the next screen. I'll show you. If you go down to the integrations, this is where you can set up any forwarding of the data to whatever service that you're using. So this particular one is used to forward the data onto the Grafana instance and the InfluxDB. So super handy. I will have links to how to set that up in the description box below. You can check that out. So now we're receiving data. Awesome. Moving on. This is the Grafana interface. You can see that there's a couple new lines on each of these graphs here, and that is the sensor that I just plugged in. It's kind of getting set up. You can see that they sometimes diverge a little bit. This one's 35 versus 45. The TVOC is just about what the other ones are. This one, the temperature is just about aligned with the other one. Is a little bit quote unquote hotter, I guess you could say. And this guy is right around the same. And this guy again is just coming out of line. For the CO2, it starts out at 400 and then it ramps up from there. About these two guys, I've actually used the scale that is provided. So this guy is the BME 680. So this is on a different board, on a different sensor. But what I've done is I've taken the information from the datasheet and I've turned it into a scale. And then this one is again a different sensor, a different board, but it uses a scale that could be applied to the same exact sensor on the particle squared. Setting up Grafana is relatively straightforward. It was actually a pleasure. I haven't found a better Internet of Things dashboard yet, and I've tried a bunch of them. So if you want the best of the best, it's $5. All you need to do is spin up a server on DigitalOcean and run a couple commands, and man, you have an awesome IoT interface for data collection, everything. Plus, you can set up alerts. So if, like, say the pressure goes above XYZ value, you can actually have it send you a text message or a Slack message or they have everything. So depending on what service you have, it will probably work with Grafana. You can see I'm also hosting it myself. I use my own domain name. It's just easier to get to it that way. So let's take a look about how the data actually gets kind of funneled in here. So if I go to the humidity and I go to edit, so I'm in the edit menu right there. I have a few different lines here. So once you start publishing to your InfluxDB database, you'll start seeing some options here. So these options come up. They're the different sensor values. So for, say, another device that has many other ones, it will give you everything, which is awesome. There's no guesswork. It's there. it just checks it for you. And then what I'm doing is I'm actually filtering by the device ID. This is the same device ID in the particle console. So if you go back here, it's this one. Then we're taking the value, we're taking the mean. If you see, if I play around with this fill option, if I go to null, it shows up as dots. So those are actually the points at which we receive data. For continuity's sake, it looks a little bit better if it's just set to none or set to linear. It'll actually create a nice kind of line. There's no interpolation, it's just from one point to the other as far as I know. You can go to visualization, you can change things up exactly how you want it to look like. I've also set, you can set the units on the y-axis. This is pretty great to whatever value they have in their database. They have almost everything. Even for the particle squared, it has all the units. So it has micrograms per meter cubed. It has parts per billion, parts per million. It has everything. So whatever you're measuring, it likely has it. And then let's see, I think that's pretty much it. And then this is actually where you set up the alerts. So you can create an alert. You can set it to check if the value is above a certain level, and then it'll send you a message. You can use it to, right now I have pushover configured. You just send yourself a message saying, hey, this is over the level, by the way. So this is Grafana in a nutshell. If you want to set your own up, you can check out the link below with particle squared, of course. And I'd love to see what other folks use particle squared for. This is not the only use case, but this was the kind of logical one for me. So check everything out below. I've got the source. I've got the store page, so if you want to buy one, I do have a couple left. So feel free to buy one. I really appreciate it. And also how to set up Grafana. I have a whole article on that. I have a whole article on particle squared. So there's a lot of resources you can check out below, kind of continuing your learning process. Thanks for checking out this video. I have more coming out very soon. I have another project that is using particle squared. So you should definitely come back, check it out when I get that video up. All right, thanks for watching.